Alright, so this is a video for the 2011 AP Chemistry Free Response, question number 5. Alright, so we start off with hydrogen is an organic compound with the formula N2H4. So in the box below, complete the Lewis electron dot diagram for the N2H4 molecule by drawing in all the electron pairs. So, well, first you figure out how many electron pairs you have. So there's 5 electrons from each nitrogen atom and 1 from each of the hydrogen atoms for a total of 14 electrons between 7 pairs. So when you draw them in, you should get this. So there's bonds to each of the hydrogen atoms as well as a lone pair above each of the nitrogen atoms. Alright, so for part B, on the basis of the diagram you completed in part A, do all 6 atoms in the N2H4 molecule lie in the same plane? And the answer is no, because the molecular shape of N2H4 is a trigonal pyramid. Alright, for part C, the normal boiling point of N2H4 is 114 degrees Celsius, whereas the normal boiling point for C2H6 is negative 89 degrees Celsius. Explain, in terms of intermolecular forces present in each liquid, why the boiling point of N2H4 is so much higher than that of C2H6. And the basic reason for that is that N2H4 has more intermolecular forces. Specifically, N2H4 has London dispersion, dipole-dipole, and hydrogen bonding forces, whereas C2H6 only has London dispersion forces because it's unlike N2H4, C2H6 is nonpolar, so there's no dipole-dipole, and there's no hydrogen bonding. So the stronger IMS in N2H4 result in a higher boiling point. Alright, for part D, write a balanced chemical equation for the reaction between N2H4 and H2O that explains why a solution of hydrazine in water has a pH greater than 7. So, when you combine N2H4 and H2O, they make N2H5 plus and OH minus. And the reason for having a pH greater than 7 is, well, there's hydroxide in the product side, and that's a base, and bases have a pH greater than 7. So the resulting solution has a pH greater than 7. Alright, for part E, is the reaction given an oxidation reaction, an acid-base, or a decomposition reaction? And, well, it's not an acid-base reaction. There's no acids or bases present, and there's nothing decomposing, so it's an oxidation reduction. And when you find the charges for each atom, you find that well, it's an oxidation reaction because nitrogen changes from a negative 2 charge in N2H4 to a neutral charge when it's just N2, and oxygen changes from a neutral charge of 0 when it's O2 to a negative 2 charge when it's an H2O. Alright, so for part F, predict the sign of entropy change, delta S, for the reaction and justify the prediction. Well, for entropy, that's effectively the amount of chaos in the reaction, and gas molecules have more chaos than liquid. So in the reactants side of the equation, there's only 1 mole of gases and 1 mole of liquids, and then in the product side there's 3 moles of gases. So there's more chaos, which means delta S is positive. Alright, for part G, indicate whether the statement written in the box below is true or false. The large negative delta H0 for the combustion of hydrazine results from the large release of energy that occurs when strong bonds of reactants are broken. And this is false for 2 reasons. First, energy is released when bonds are broken, not when they're formed. And second, because the reactants are relatively weak compared to the bonds in the products.